This is section 6, and what we're going to do is we're going to go over the rational zero theorem. And the rational zero theorem has these symbols here, the P and the Q. And it's a fraction, P over Q. And what the P stands for is the factor of constants, and what the Q stands for are the factors of the leading coefficient. So here is exactly what your book asks you to do. It says list the possible rational zeros of the function using the rational zero theorem. So remember, we have the P over Q. So let's go through and figure out what all of our P's are, and then we'll figure out what all of the Q's are. Now the P, if you look back into our notes, it says are all the factors of our constant. So if we look at this, our constant is the number all by itself, so this 28. So 1 and 28. Those are factors of 28. 2 and 14. 4 and 7. And so those are all the factors. And what we're going to do is we're going to put plus minus on all of these, because we know that two negatives also make a positive 28. Now we're going to go to the Q's. And if you go back in your notes, the Q's are the factors of your leading coefficient. So let's look for the leading coefficient, which is the number that starts off this entire polynomial here, and it's a 1. Well, that's easy because the factors of 1 are just 1. And we're going to put a plus minus in front of them. Now, we have our P and we have our Q's all wrote out, and the only thing we have to do is list them as a fraction. So because we're listing all of these, we're going to say 1 over 1, 2 over 1, 4 over 1, and so on. And so we have them all over Q. So here are all of our P's over our Q. And we're just going to put the plus minus right in front of them. That way we have covered every single P over Q. Okay, now the next one, same directions. I didn't type them out again. But the P are going to be all your factors of your constant, which is 9. So 1, 9, 3 and 3, but there's no point of repeating it. So we put plus minus in front of them. Now we do the Q, which is the factors of your leading coefficient. Remember, the leading coefficient has the highest degree, which is a 4 here. So the leading coefficient is a 2. And all the factors of 2 are just 1 and 2. With the plus minus right in front. Okay, now what we're going to do is we're going to do our P over Q. So we're going to take the first P, which is 1, and put it over 1. The second P, put it over 1. The third one, and put it over 1. Whoops. Okay, we just covered all of the P's over the first Q. Now we need to do the same exact thing for the second one. So we have 1 over 2, 3 over 2, and 9 over 2. And put plus minus in front of each of them. Now you always want to look through the list and see if you have anything repeated. And I do not. Every single one of them is different, and so these are the answers. Okay, now it says find all real zeros, which is a little different, and your book will do this too. The previous problems we just did find all possible rational solutions, but we're actually going to find the real ones of this one. We're going to do the same exact thing. Okay, so we're going to find all of the values that are 25. 24. Okay, so, and look at here, we have a negative 24, so you have to keep that in mind. But because we put the plus minus in front of all of them, that will take care of it. So 1, 24, 2 and 12, 3 and 8, and 4 and 6. Plus minus, all the way down. Okay, now for Q, we're going to find the leading coefficient, which is 1. And we're going to do the factors of 1, which is easy. Okay, so now that we have all of these, we're going to put all of the rational zeros down, meaning all of the ones that we have, which are basically all of these over 1. Another way of writing this is just saying 1, 2, 3, 4, 6, 8, 12, and 24. Because we know that any one of these numbers over 1 is just that number. All right, so now this is where the next step comes in. We've done everything exactly how we've done it before. And I gotta get my calculator out here. We're gonna go to the y equals, and we're going to punch in this x to the third minus 12x squared plus 35x minus 24. Okay, if you don't have a calculator at home, you need to write this step down saying that you plugged the equation into your calculator. And that's what I'm doing right now. And then once you have that in, you're going to go to your table, so second graph, and you're going to find where there's a plus 1, so which is basically 1. So go to your x values and scroll until you find 1, which will take me a minute here. Okay, here we go. So on your x and y chart in your calculator, I have 1, 0. If this answer over here is a 0, that means that positive 1 is a real solution. So we're going to put 1 as a solution. Now check negative 1. And I show that negative 1 in my x and y chart is a negative 72. So that means that this is not a real 0. Negative 1 is not part of it. You're going to do that for every single one of these. So go to 2. Okay, I have 6 across from it. So that's not 1. Go to negative 2. Still not. Now go to 3. 3 I have as a 0. So that's going to be one of them. Go to negative 3. I have negative 264. So that is not going to be a 0. Then go to 4 in your x and y chart. Not a 0. Go to negative 4. Still not a 0. Go to 6. Not a 0. Okay, basically what you can do is you can start at negative 24 in your x and y chart, and then just take your finger and push down until you see a 0, and you've reached positive 24. So far I have 1 and 3, and I just found another one. And you go all the way until you reach positive 24, and then you stop. These are the only 3 zeros that I found. And you can check the solution, because whatever your highest degree is here, which is a 3, you will have that many solutions. Okay, so here's one that you can try on your own, and you can pause the video, or you can just watch and do it along with me. So we're going to first find the P and the Q. The P is the numbers that are going to be your constant. So 30, we're going to find factors of 30. Squeeze it in here. And remember, these all get plus minus. Okay, now Now the factors of the leading coefficient is a 1, and I like these because that's easy. And if we list these all over each other, which is just really the number that you see, plus minus, all the way down. Okay, so here's all the possible ones, and now we're going to check the real ones. So go into your y equals, clear anything out, and type in x to the third minus 31x minus 30. Go to your graph, or I'm sorry, your table. The highest number that we have is negative 30 and positive 30. So let's go to negative 30. And what you're going to do is you're going to scroll all the way to positive 30, but go slow so that you can write down anything that has a 0 in the y, which I do. I have negative 5, and I have negative 1, and I have positive 6. Keep going until I hit positive 30. And I don't have any more. So I have 3 solutions, negative 5, negative 1, and 6. Those are the real ones of the graph, and these are all the possible ones. Okay, now if you get to this point in the notes, it says, use the graph to shorten the list of possible rational zeros of the function, and then find all the real zeros of the function. I'm going to tell you right now, once you get to this part in the book, as long as you're watching the video, you do not have to do any of these problems, okay? So anything that has these directions, you do not have to do. And of course, if you watch the video, then you'll be happy because those who don't will not know this and be doing those problems. And this is just one to try on your own, but we are not doing these problems that say use the graph to shorten the list. So do not do. And that is all.